Okay, here we go, part 3 of the algorithm lesson, and this is an example. The example is write an algorithm for doing laundry. And so here we have it. This is my algorithm, and I'll go through it real quick, and then we'll talk about how this isn't actually a very good algorithm. It says split the dirty clothes into piles of light colors. If the load of clothes is white, use hot water. Otherwise, use cold water. 3. Add soap to the water as it fills. Add clothes to soapy water. When load is done washing, put it in the dryer. Repeat steps 2 to 5 for next load, if any are left. Okay, which seems about right. If you've, I don't know if you've ever done your own laundry or watched somebody at home do laundry, but it's about like this. And notice that this meets most of the qualifications for a algorithm. An algorithm has to be finite. Well, certainly I see the 6 steps are finite, and say, well, what about, you know, the 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 looping process? The looping process, will it stop? Well, this says if any are left. So if eventually, depending on how many loads of laundry we'll have, we'll end up being washing all of the loads of laundry. So for sure it's finite. So finite, yep, for sure. What about definite? Definite means, do we know what to do at every single step? Well, this step right here is not that clear. In fact, there's a couple not clear steps that I would argue that are not definite. Into piles of light colors. Well, how alike do colors have to be? Like, do they have to be exactly the same color so we're going to have 27 loads of laundry? Well, no, not really. You know, probably like whites and darks, and then other colors, maybe 3. And this should be expanded probably to say, you know, of approximately light colors, and how big's the pile, right? These are things that if you've never done laundry are not definite. Not definite. Don't know. So probably we could clean this up. Um, uh, Use hot water. You know, that's sort of controlled by the machine. So you could say how hot, but it's controlled by the machine. Add soap. How much soap? We don't know, right? And it depends on the size of the lawn. So depending on the audience, this might need to be a little more clear. Um, the rest is actually pretty good. When load is done washing, put it in the dryer, and then, you know, it doesn't say things like there's little details missing, like closing the lid and taking the clothes out of the dryer after they're dry, and so on and so forth. There's lots of little details we could add, but I wanted to talk about the definite part. It's not that definite. A lot of these things are a little bit unclear. What are the other aspects of an algorithm? Well, input and output. What would be the input? Well, the input would be the dirty laundry, right? That would be the input, dirty laundry. Output, or input would also be the soap and water, probably. All these would be inputs. Outputs would be the clean laundry, right? Clean laundry. And hopefully you can, well, if you can't read that, at least you can hear me. So what's the last characteristic of complexity? And I would say that the answer is probably not, because the first step wasn't definite. You know, split the dirty clothes into piles of light colors. How many piles? How big are the piles? Is this an effective algorithm? Probably not, because some of the steps aren't definite. Okay, I think that's all I had to say here. You've got some exercises to do, and those um, exercises are similar to this. And these are the sorts of things that I'm asking you to do. And remember that if you have any trouble, I'm just standing right over there waiting to help you. That's all I have to say about that.